ISA Aerospace launched from the Andøya spaceport in Norway on Sunday. The Spectrum rocket cleared the pad, but within seconds of launch had steering issues which after 30 seconds led to the vehicle plunging back to Earth and exploding. Luckily, the vehicle missed the pad, but not by much. ISA is a well-funded German space startup that was founded in 2018. It's developing the Spectrum Orbital-class rocket, which uses 9 Aquila engines on the first stage and 1 vacuum-optimized engine on the second stage. The vehicle can carry 1 ton of payload to orbit, although for this first flight no payload was carried. Before we cover the flight, let's look at the engines in more detail. Aquila engines. Aquila is the name of Spectrum's engines. They are fully in-house designed and manufactured like the rest of the vehicle. The engine cycle is a gas generator, a relatively simple engine design that burns a small amount of fuel to power turbo pumps that supply high-pressure propellants to the main combustion chamber. The exhaust from the gas generator is expelled separately, making it less efficient as some other engine designs. For instance, Rocket Factory Augsburg, another German space startup, are using staged combustion in their engine design. ISA's choice of fuel also reflects practicality. The engine uses propane, which is widely available and inexpensive. Storage and handling is simplified as the fuel doesn't need very low temperatures needed for some fuels like methane. Propane is clean burning, unlike kerosene, producing minimal coking and soot. This reduces wear and tear on the engine, but since ISA doesn't have any plans for reusability, this doesn't seem to be a factor in their choice of propane. Okay, let's talk about the first flight of the Spectrum vehicle. First test flight. The test flight was conducted on Sunday, the 30th of March 2025 at the Andøya spaceport in Norway. From the official livestream video, we can see the vehicle takes off from the pad without problems. Shortly after launch, steering problems become evident, as we can see the engines gimbaling or moving to keep the vehicle on the correct flight trajectory. Quickly afterwards, the vehicle flips over, the flight termination system cuts off the engines, and the vehicle crashes a short distance away from the pad in the water. Debris can be seen flying in all directions as the fuel in the vehicle explodes, sending a mushroom cloud into the air. No injuries to personnel or other infrastructure is reported. ISA Aerospace said on their X account, "With this test flight, we were able to successfully gather valuable data and experience for future missions. Thanks to strict safety procedures from both ISA Aerospace and Andøya Spaceport, all personnel remain safe at all times." Unquote. Prior to the launch, ISA Aerospace CEO Daniel Metzler announced that the company was already working on its second and third Spectrum rockets, adding that it would swiftly return to the launch pad no matter the outcome of the first flight test. Unquote. So we can expect the Flight 2 hardware to be ready later this year. The question though is, what went wrong? Let's examine the launch in more detail. Problems with the steering of the vehicle. What is very obvious when watching the launch is the vehicle is struggling to maintain the heading of the vehicle as it seems to veer off course, then correct, and then it flips over. This suggests problems with the GNC system. GNC stands for Guidance, Navigation and Control. Guidance is about determining what the vehicle should be doing. What is the desired path or trajectory? Sensors and software are used to plan the route of the vehicle, figuring out the best plan or maneuver as the vehicle ascends. Navigation is about figuring out where the vehicle currently is right now. This is determined using GPS and sensors. Navigation provides real-time position, velocity and orientation data. The orientation is important because as we see in the video, the vehicle tips over. An IMU or inertial measurement unit device is used to determine the orientation, angular velocity and acceleration. Control is the hardware used to steer the rocket. In Spectrum's case, the engines gimbal or move to steer the exhaust plume. It's not only hardware though. Software is used to precisely and accurately command the hardware. Was the failure caused by a GNC positive feedback loop? What is a GNC positive feedback loop? The GNC system is the brain of the rocket, constantly checking the best path or maneuver to keep the rocket heading in the correct direction in all 3 dimensions, technically called pitch, yaw and roll. A positive feedback loop occurs when an error in one part of the system amplifies itself instead of being corrected. Imagine turning the steering wheel in a car, and instead of going in the expected direction, the car turns harder in the opposite way. Except in a rocket, this happens in 3 dimensions at supersonic speeds. If a positive feedback loop kicked in, a small deviation in orientation could have been misread by the navigation sensors or software, prompting the control system to overcorrect in the wrong direction, worsening the deviation until the rocket lost stability. What could cause a positive feedback loop? Sensor problems. The IMU, the device that measures acceleration and rotation, could have misinterpreted the motion of the vehicle. This could be caused by oscillations induced by engine starting or winds at the launch site. Control over reaction. The GNC software, that should have corrected minor deviations, sent a command to the engine gimbals that overcorrected the deviation, causing the vehicle to pitch over. Feedback amplification. Instead of dampening the error, the system kept overcorrecting in the wrong direction, creating an unstable oscillation. This is a classic positive feedback scenario. Think of a microphone too close to a speaker when the sound builds uncontrollably. Rockets are hard to control just after launch. This is due to their high thrust and low velocity, making the vehicle dynamically unstable. It could be this brand new vehicle has unknown or not well understood vibrational modes or thrust asymmetries caused by its carbon composite structure or 9-engine cluster. Any flaw in the control system, such as overly aggressive gain setting or a sign error in the feedback loop, e.g. mistaking left from right, could induce a catastrophic tumble. Spectrum's failure resembles those cases of GNC issues, a sudden, unrecoverable attitude loss right after launch before aerodynamic forces or staging could dominate. These steering issues and GNC failures are relatively common in new vehicles. Take a look at this graphic of small space startups and their first launch vehicle since 2000. Just to be clear with this list, I'm not including Blue Origin as I don't consider it a startup. It's owned by a billionaire. Also, I haven't included ULA because it's a joint venture between two aerospace primes with a lot of knowledge and technology from the US military. As you can see, it's very hard to have a successful first launch of a new vehicle for small space startups. In fact, you could argue the success from iSpace is more down to them using a solid rocket booster that was likely adapted from the Chinese military. I could have added the Japanese Space One failure to the list, but I ran out of room. First flights are vulnerable. First launches are notorious for uncovering GNC issues. SpaceX's Falcon 1 failed 3 times before succeeding, and Rocket Lab's Electron flopped on its debut due to a telemetry glitch misdiagnosed as a control failure. We don't know if the launch failure was caused by GNC issues. It could simply be an engine failure, or underperformance causing a thrust imbalance that was not recoverable. It could be a loss of an engine due to vibrations at launch, or an unseen fuel leak. It could be the primary structure buckling or flexing under load, or something as simple as a software bug. The possibilities are endless. It's a brutal reminder that the real world has a way of humbling untested systems. Reactions to the first flight. Daniel Metzler, CEO and co-founder, said this about the first flight. Our first test flight met all our expectations, achieving a great success. We had a clean liftoff, 30 seconds of flight, and even got to validate our flight termination system, unquote. On the official ISA Aerospace X account, what a success! At 12:30 p.m. CEST, ISA Aerospace's Spectrum launch vehicle successfully lifted off from Andøya Spaceport in Norway. The launch vehicle was terminated after approximately 30 seconds in flight, and the vehicle fell directly into the sea. The launch pad seems to be intact, unquote. What's next? From ISA Aerospace's X account, with Spectrum 2 and 3 already in production, ISA Aerospace is preparing for its next launch, unquote. Well, obviously this wasn't the outcome ISA was hoping for. It's worth noting that the first launch of a vehicle that includes tens of thousands of components is likely to have issues. Still, as Elon Musk likes to say, the data is the payload. ISA will learn more from this short flight than months of testing on the ground. Let's hope they can quickly troubleshoot the issues and get their second vehicle on the launch pad later this year. What do you think? Do you think this is a GNC issue, mechanical failure, software bug, fuel leak, or something else? Leave your comments below. For a more in-depth video on the company, check out my previous video. It should be showing on the screen now. That's all for this video. Thanks for watching. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.